Hello friends, you are watching C programming tutorial classes brought to you by Pro Training. Well friends, in this program I'll be teaching you the C program to demonstrate the relational operators. To demonstrate the relational operators, I'm going to use the three variables here, respectively A, B and C. And I'll initialize these variables with some value. Okay, let's assign 2 to A, 3 to B and 4 to C. Right, so now I got 2 in A, 3 in B and 4 in C. The result of relational operation is going to be either true or false. So let us see that. And to see the result of relational operator, I'm using the printf function along with the operation, right? So I am doing here. So first I will check for A is more than B. So this will print. This will be printed as it is. So let's go and try this. CLR SCR. Control F9. So A is more than B, so there is nothing change in it. So to get the result of A is more than B or not, I must use the relational operator here. So for that I am doing this equal to %d. So this is the place where I'll be getting the true or false, which means 1 is equal to true and 0 is equal to false. So this is the placeholder for that. Okay, so now put a comma, and here I am talking about the relational operation. A is more than B. So this is the operation, right? A is more than B. So it doesn't matter if we give the spaces, if we put the spaces between the expression. Okay, this will also work very finely. Control F9. So A is more than B is equal to 0. That means A is not greater than B. So can you see here, A is 2, B is 3. 2 is not more than 3, right? So let's go and copy this statement. Control insert and shift insert. Now I'll change the operators here. A is less than B, A is greater than or equal to B, A is lesser than or equal to B, A is equal to C, A is not equal to C, right? So let us change here as well, lesser than B, right? Control F9. So A is more than B, which is wrong. A is less than B, right? A is more than or equal to B, wrong, because A is 2 and B is 3. A is lesser than or equal to B, right? A is equal to C, no. A is not equal to C, right? So these are the relational operators. So the relational operators going to return either true or false, which means 0 or 1. So now friends, let's go and perform the logical operations. So friends, in this program I'll demonstrate the working of logical operators, how they work, and we'll see how they result in different situations, in different logical conditions. Okay, so for that I'm going to use three different variables having three different numbers, right? And I'll initialize these numbers with some value. A is equal to 1, B equals to 2 and C equals to 3 and C equals to 3, right? So friends, just look at this statement. I'm telling here the logical operation A is more than B or B is more than A. So this will return true if either the condition is true. If any of these conditions evaluates to true, so the OR statement will return the true. Is A more than B? No. Is B more than A? Yes. So the second part of the condition got true, then I'll get the result as true. So let's run this program. I'm sure I'll not get anything, just the string of this one. I've just got whatever I've written in this statement. So let's have some appropriate condition here. So let's put comma. A is more than B or B is more than A, right? So look at your friends. So I've separated the conditions with the parenthesis and OR operator is present here. So equals %D, right? Control F9. So A is more than B, B is more than A, which value is to 1. So once mean so I've got 1 means the condition is true, because or will produce the true result when either of the two condition is true. Let's copy this and paste for other operations. So in the second printf statement, I got the logical AND operation. So this is true when both the conditions are true. Let's go and run this. Control F9. So A is more than B? No. B is more than A? Yes. But the final result is false, because both the conditions should be true to produce the true result. So this is the format of NOT operation. So it usually reverses the result, right? B is more than A, which is true, but we still get the result as false. That is what NOT does. So I'll put here NOT B more than A, right? Let's run this. Control F9. So B is more than A, which is true, but I've got false as result because I'm performing the NOT operation. So well friends, I hope you understood the logical operators. So friends, I'll demonstrate the bitwise operators in this program. For that, I'm going to take two integers here, A equals to 1 and B equals to 1 as well. Okay, so here I got A equals to 1 and B equals to 1. And now perform the bitwise AND operations. So remember, the bitwise operators work at the bit level. If I say A and B, that means we are going to have the AND operation. That means logical multiplication between A and B. Right. So to store the result, I'll use one more variable called C. Now go and print the result. C equals to A and B, right? So A and B. Let's go and print the result. Printf A and B equals to %D, comma C. So now C has got the result after the logical multiplication between A and B. So try to assume the binary sequence of 1. So and we are doing the logical multiplication 0 0 0 0 0 1 at the end, 0 0 0 0 1 1 at the end. So when both are ones, so the result is also 1, right? So let's find out that. Control F9. Yes, it is. So when I change this to 0, so it's obviously be 0, right? So let us try the OR operation, A or B. So this is A or B. So A is 1, B is 0, which means 0 0 0 1 or all zeros. So we are doing OR operation between 1 and 0. Control F9, which is 1, because 1 or 0 is 1, right? When we have both ones, obviously be 1. Yes. When we have both zeros, so the result is 0, right? Yes. And now I'll show you how bitwise XOR works. Okay, so the bitwise XOR operator is represented with this symbol, right? The caret symbol. Normally XOR will produce the true value when either of the input is true or either of the input is 1. When both the inputs are same, it will produce the false, right? If I say A XOR B here, and if I go and print the C, let's see what happens, because now A has got 1 and B has got 1. When I perform A XOR B, let's see what happens. Control F9. A XOR B is equal to 0, because A and B are having the same values. When I change this to 0 and 1, let us see now, A XOR B is producing the result 1, because XOR will produce the true value when either of the input is true or either of the input is 1. And now I'll show you how bitwise right shift operator works. So here I've got 8 in the variable A, and now I'm going to shift the bits right towards right in the variable A. B is equal to A right shift 2. So this means this right shift operator is going to shift the 2 bits to the right. So the variable has got the decimal 8 in it, and the binary equivalent of 8 is this, of 4 zeros, 1 and 3 zeros, right? So when we try to shift the bits towards right by 2 positions, the resultant will be this one. So you can figure out with the digit 1, the digit 1 has moved to this place. That means we have shifted the bits towards right by 2 positions. So every bit has shifted towards right by 2 positions. So the empty places here at the left side will be filled up with the zeros. So after shifting, the resultant is this, which means this will produce, if we try to produce the resultant of this, we'll get the decimal 2. So let's find out that. So now let's go and print the result. Let's see what happens. Printf A right shift 2 equal to let me add the clear screen here. Yeah, so A right shift 2 results in 2. So this is what happens when we shift the bits to the right by 2 places. So let us perform the left shift operation. So I'll just replace the operator which is here, left shift, right? So A left shift by 2 places. Let's run this program, Control F9. Now in this case, the value after bits being shifted to left by 2 places, the value is 32. So I hope you understood this concept. Now I'll show you the last operator, which is called as ones complement. When I perform the ones complement here, so this we use the tilde operator to perform the ones complement. So let's run this program, Control F9. So now the complement of 8 is -9. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter, and join our group on LinkedIn. Thank you.